Hello, dear students. This is the third practical work of discipline hygienic certification of workplaces for students of the educational program 6B 11201 Life Safety and Environmental Protection. The topic of the third practical work is called Assessment of Working Conditions by Indicators of Air Clean Lines. This presentation was prepared by Assistant of Mine Aerology and Labor Protection Department, Isakov Bigjan Yerbulatovich. The purpose of the work: training in practical skills for assessing working conditions based on air clean lines indicators. Lessons plan: introduction to the theoretical part of the material, the procedure for performing the work, task for practical work. Let's start with the main idea. The clean lines of the air environment is characterized by the presence of industrial dust in it. Aerosols of mainly fibrogenic action, for which the classification of working conditions is carried out, are industrial dust. Dust is small solid particles that can be suspended in the air and remain in it for a fairly long period of time. Industrial dust is a collection of fine dispersed solid particles that are formed during production and are suspended in the air for a long time. The dust, together with the gas in which it is located, forms a dispersed system. In this system, solid particles make up the dispersed phase, and gas makes up the dispersion medium. Dust suspended in the air is called a dust aerosol. Under the action of gravitational, inertial, and other forces, the dispersed phase is separated from the dispersion medium. Dust that has settled from the air on various surfaces is called dust aerogel. Both aerosols and aerogels are not stable under normal production conditions and can change from one state to another under the influence of various factors. Dust is classified by origin and material composition, dispersion, harmfulness, and explosion hazard. By origin, all dust is divided into organic and inorganic. Organic dust includes vegetable such as wood, flour, sugar, cotton. Animal: wool, leather, horn, bone, as well as some types of chemical dust, such as plastics, chemical fibers, and other organic products of chemical reactions. Inorganic dust includes metal, like copper, iron, lead, etc., and mineral dust, such as quartz, cement, lime, etc. In production, Mixed dusts with a predominance of certain components are more common. According to the explosion hazard of dust, they are divided into explosive, like coal, fluor, sugar, and non-explosive, quartz, rock, etc. Many non-flammable or difficult to ignite substances become explosive in a dust-like state, like an aluminum. In terms of harmfulness, dust can be poisonous, like lead, mercury, arsenic, copper, and non-poisonous, like rock, coal, cement, iron, etc. Dust dispersion is divided into the following groups: gravity, Stokes, and Brown. The class of particles is determined by the deposition rate, so the behavior of the aerosol in the airstream. For gravitational particles, it is characteristic that their deposition rate is proportional to the accelerated gravity. Stokes particles are characterized by a constant value of the deposition rate in stationary air. Brownian particles obey the laws of motion of the medium and are not separated from the flow. Some of its physical and chemical properties are associated with the dispersion of dust, an increase in the total surface of dust particles, an increase in the physical and chemical activity of dust particles, the ability to absorb, coagulate, settle, explosive, electrical properties. Dust particles are charged with electric charges. Particles of oxygen oxides and non-metallic substances, as a rule, are positively charged, and basic oxides and metals are negatively charged. The sign and magnitude of the charge of a speck of dust have a significant impact on the efficiency of its deposition in the air. So, even non-poisonous dust with a significant concentration of it has a harmful effect on the human body. Dust enters the digestive system when ingested, when eating and smoking with contaminated hands. When working in a dusty atmosphere, a particle of dust, together with air, penetrates into the respiratory organs. Larger dust is delayed by the mucous membrane of the upper respiratory tract and leads to various diseases. Finer dust penetrates into the deep respiratory tract, alveoli of the lungs. A long stay in a dusty atmosphere can cause occupational lung diseases, which bear a common name pneumoconiosis. I'm sorry. According to the type of dust that causes lung diseases, there are four types of them. Silicosis, which occurs when inhaling quartz dust. Siderosis, under the action of iron or dust. Asbestos, under the action of asbestos dust. And anthracosis, under the action of coal dust. The most common and severe form of coniosis is silicosis, which not only affects the lungs, but also causes functional disorders and changes in the nervous and vascular systems, blood circulations, digestions. Therefore, pneumoconiosis is a complex and severe disease of the entire body. The disease of pneumoconiosis depends on a number of factors, the most important of which are the material composition of dust, the size of its particles, the concentration in the inhaled air, and the duration of a person's stay in a dusty atmosphere. In this slide, you can see the Republic of Kazakhstan has established standards for the maximum permissible concentration of dust in the air of the working area of industrial premises. From the point of view of occupational health, industrial aerosols are classified primarily by the nature of their effects on the body. Depending on its chemical composition, dust can have a fibrogenic, toxic, allergic, photosynthesizing, carcinogenic, ionizing effect. Most often in their industrial activities, people encounter fibrogenic types of dust that cause prolonged inhalation of high concentrations of the development of a pathological process in the lung tissue and bronchi, leading eventually to sclerotic changes and emphysema of the lungs. The effect of fibrogenic types of dust is due to the direct presence of solid dust particles in the respiratory organs, which themselves have a pathological effect on the tissues. The dust load on the respiratory organs of the worker is the actual or predictive value of the total exposure to the dust dose that the worker inhales during the entire period of actual or assumed professional contact with a factor. The dust load on the respiratory organs of the worker is calculated from the actual average concentrations of aerosols of mainly fibrogenic actions in the air of the working area, the volume of pulmonary ventilation, and the duration of contact with dust. You can use this formula. Here, in this formula, K is the actual average daily dust concentration in the employee's breathing area, N, number of working shifts in a calendar year, and Q, volume of pulmonary ventilation per shift. Reducing the incidence of pneumoconiosis is provided through the use of a complex of engineering, medical, sanitary, and organizational measures. Among the measures to combat industrial dust, it is important to conduct regular monitoring of the dustiness of the air in the working area of industrial premises. The concentration of dust in the air can be determined by an optical method, which is based on the principle of registration of the light flux passing through the dusty air or filter material. A radioisotope method, which is based on the principle of registration of beta or alpha particles through the dusty filter material devices. The electrometric method, which is based on the principle of registering the total charge of electrified aerosol particles with IKP devices. The acoustic method, which is based on measuring the parameters of the acoustic field depending on changes in the constant of the atmosphere under study. So how the work is performed? To determine the dust content in the air, use aspiration device automatic ejector aspirator AERA designed to draw air through the filter. For this purpose, an aspirator and a dust chamber are used. In this method, one of the aspiration devices, the test air is drawn through the filter, which is weighted before and after sampling. The amount of stretched air is measured by a rheometer, rotameter, or any other method. The amount of extended air and the weight of the filter determines the dustiness of the air in weight units. From the cylinder with compressed air, which is number 2 in the picture, through the reducer, air is fed through the switching device to the atmosphere through the device. This Ventura tube device ensures that the dusty air is drawn through the filter cylinder 1 at a constant speed. A constant speed of stretching is provided by the device automatic controller. In a number of industries where dust is particularly dangerous to health and the process itself, a flow through ultramicroscope is used. It can be used to determine the number of dust particles and approximate the fractional composition of the dust. When taking a dust sample, the time of sampling and the amount of air drawn are recorded. After sampling is complete, the filter is removed from the cartridge and reweighted. The dust content in the air is calculated using this formula. Here you can see that C is the dust content in the air. First M, mass of pure filter. The second M, weight of the filter with dust. And V, volume of air drawn through the filter. The second device that you can use is called dust meter Canomax. It's a piezo balanced dust mass concentration meter, which is designed for monitoring the dustiness of the environment, evaluating indoor air quality, monitoring production process, and laboratory research. Advantages: direct measurement method. Data is displayed on the screen, can be printed on a printer or sent to a computer. The available software facilities data output and processing. It is easy to use, doesn't require special training. Tasks for practical classes. Task number 1, turn on the measuring device. Task number 2, need measurement of air. Task number 3, commit and write the data of the device. Then immediately after sampling, measure the temperature, humidity, and atmospheric pressure at the sampling point. Calculate the dust load on the respiratory organs of the worker using the formula which was given earlier. Comparing the data obtained with existing standards give a sanitary and hygienic assessment of the air for dustiness. Also, you have to answer these control questions. What is the dust? Its species. What is the harmful effect of dust on the human body? What is the pneumoconiosis from which it emerges and what are its varieties? Methods for determining air dustness. The principle of operation of the ejector aspirator and its device. To answer these questions, you can use this list of sources. Thank you for your time and goodbye.